Good morning. We continue to talk about temperature control units. In the previous video, we talked about the various types of fluids that are used. Now, let's talk about the types of units based on the fluid. Let's talk about water temperature control units. Typically, we can use temperature control units with an atmospheric circuit or a pressurized circuit. The main difference is primarily the temperature range at which we operate with the unit. Up to 90 degrading, we can obviously use an atmospheric unit. Beyond 90°, due to obvious boiling issues, we must use pressurized water units, meaning with a closed, sealed circuit that withstands pressure, like a pressure cooker. Obviously with other types of safety measures, but this is a topic we might address at another time. Pressurized units, therefore with pressurized water, are often used even for low temperatures because they have the significant advantage of they can be installed at any point in the system without adhering to height restrictions. Let me explain better. An atmospheric unit, precisely because of the atmospheric circuit, which is an open circuit, needs to have the expansion tank at the highest point of the system. Otherwise, due to the principle of communicating vessels, the system would empty. A pressurized unit, essentially, is a closed, sealed circuit, so the water is circulated. Once the air is vented at the high points of the system, the unit can operate regularly without issues. Clearly, depending on the type of system, we will choose the most suitable unit type. Many times, the atmospheric unit has significant advantages over the pressurized one. The pressurized unit, as I mentioned earlier, has the advantage that once we have completely vented the air, the circuit is full, the water circulates, and there are no problems. However, we have industrial circuits, processes, where the circuits are truly very complex. There are many points where air pockets can form, air pockets that are difficult to vent. At this point, an atmospheric control unit placed at the highest point of the system could be the winning solution because the pump remains below the head of the tank, thus always primed by the water, pushing the water into the system. Any air bubbles do not return to the pump, but end up in the expansion tank directly, or in the water collection tank, which is located at the highest point, venting themselves. Let's say, automatically without major issues. And this allows the pump to operate without difficulty, especially when starting up the system. It is certainly a topic worth exploring further. If you contact us, we can discuss it further. Have a good day and thank you.